Okay, so the equation for the height of buoy, so equation is going to be equation for the height. The height is going to be y equal to a times cosine of wt, let's say, where a is the amplitude and w is the angular velocity. So this is amplitude, and the w is angular velocity, and t is time. So this is angular velocity, and the t is time. That's the equation. That's the model that we are trying to build. Okay, so then now let's find the amplitude first. So a is just going to be 3.5 divided by 2. That's the middle point, and w is going to be, because it's every 10 seconds, so that's going to be 2 pi over 10, which is pi over 5 if you simplify it. Okay, so amplitude for the periodic function must be the magnitude of the total displacements in two directions. So we must consider the distance from high to low points to be twice the amplitude. So the angular velocity, must be converted from the given period, 10 seconds, using this formula. So for this particular step here, I use this. So the angular velocity equals 2 pi divided by t, and this t here is 10. So I use that, and now for the next step. Okay, so I will do this. So now the equation y equals, because 3.5 divided by 2 is 1.75. So therefore, this is going to be 1.75 cosine of pi over 5t, and that's the equation that we're interested. So the equation of this motion. Okay, so now if I want to find, let's say, so write down the equation now, determine the velocity of the buoy as a function of t, and then also write an equation, describe the motion if it's at t equals 0. So if you just plug the t to 0, then you can compute the y value here. So that's basically it, because we were interested in finding this. But if you want to find height at a specific time, then you can just plug it into this equation and find it.